Course 3, Lesson 3, it's time for word problems. I know you probably don't like them because words don't belong in math, blah, blah, blah. Absolutely they do. That is when math gets real. It's what real life involves. Usually involves you having to think through the words in the application of the problem. So when we have word problems, we're talking combining and separating today. Fancy words for add, subtract. You gotta be familiar with the concept of a formula. A formula is a common equation that helps us find a solution for lots of situations, lots of word problems. So sum and some more, right, is sometimes called the combining formula, where you've got sum and hey, why not? Let's get some more. That gives my sum or total. An equation means we're setting an amount equal to another amount. This amount, the sum plus more, equals the second amount, the total. Equation, get it? Instead of writing out the big word sum, they just show sum and some more as s plus m equals t. And we're going to use our missing number or variable knowledge, right? Solving with algebraic thinking and variables to accomplish these formulas, these equations in word problems, okay? Let me show you what I mean. In the first half of the game, Heidi scored 12 points. In the second half, she scored 15. Sounds like some and some more. How much does she score? In the whole game, she scored 27 points, right? 12 plus 15 is 27. But what if we're missing one? What if they tell us she scored 12 points, example 1. She scored 27 in total, but we don't know what she scored in the second half. How could we find it? First of all, write out your formula, s plus m equals t. And then we decide which ones do we know. We write them out. We write 12 in the first half, so sum. 27 in total at the end of the game. We're missing the more. How do I find when I'm missing more? Right? You have to take the whole and subtract the part we know, the known part. 27, use the opposite of add, take away 12, subtract 12, excuse me. That gives me the missing amount. 27 minus 12 is 15, right? Answer is 15. When you're missing s or m in our sum and some more equation, these ones you're going to end up subtracting to solve. But right, if we're missing the solution, that'll be adding, right? If you scored 5, then you scored another 2, how do I solve? I add that. But if you're missing an addend, you're going to subtract to find the other addend. Subtract from the total. Here is a story about separating or subtracting. Alberto went to the store with a $20 bill. He bought a loaf of bread and a half-gallon of milk for a total of $4.83. The clerk gave him $15.17 and change. Sum and then some went away, right? So s take away equals what's left. He had 20 bucks, takes away the 483. He's got 15.17 left. If you're missing one of these numbers, you're actually going to add to solve. And if you're ever missing the answer in a subtraction problem, well, you find the difference, you subtract, right? Just like a normal subtraction problem. So we got to identify what the variables are worth. First, got to decide what type of a problem it is. And here in the separating problem, we decide it's sum and then take away, someone away, and then what's left. We know the $20 at the beginning, and then it tells me he's got $15.17 at the end, but we don't know how much he spent on the food, the bread and the milk. They took that part away. So to solve that, we're actually going to use adding, it told us. Right? It said that up here. Solve that by adding. So you add the known parts and sorry, I made a mistake. We solve this by adding. We solve these by subtracting. That is often mistaken because you would think, just like adding, you solve these by adding, the opposite, and then you solve this one by subtracting. But you also solve this missing number by subtracting. Because if you think about it, if I was to add $20, what he started with, and then add it to his total 15, you're going to get way too much. You're going to get 35.17 here. That's not going to work, right? And I always get that mixed up, don't I? I really do. I really do. The hike to the summit began from the upper trail at 8,365 feet. Elevation of the summit, or the top, is 14,496 feet. Which equation shows how to find the elevation gain? We started at 8,000 something, ended at 14,000 something. Gain means separation or change, a difference from one to another, I believe. But they don't have the difference I would like. I want 14,000 some minus 8,000 some. They don't have that. Instead, they rearrange it and they put 14 over here and they say plus what, right? 8,365 plus what is 14,496. That one would tell me, right? I have some, and then I add some that I don't know, and this is my total. Thought it would be separating, but they don't give us an option. We could have shown it as some went away separating, I think. If you ever have to compare an amount, this amount's bigger, this amount's less. Here's the difference. That's kind of what I was doing with the last problem. And then elapse your time. If it's later, you take away the earlier and you find the difference. Year 1990 and then the year 2000, the population increases, right? What if I asked you how much time had passed? Later is 2000. Earlier is 1990. 1990 is earlier in the span of time. And you subtract to find the difference for elapsed time. There's always a lot of borrowing with elapsed time. Good review. That just means 10, right? 10 years. Okay. That's what they do in example 4. Definitely read through this lesson and get familiar. Do all the lesson practice, except for F and B and D. So A through E, and then for letter G, let's do these two. Please. Thank you, thank you.